Hi, everyone, and thank you for coming. We'll be starting in 2 short minutes. Welcome, ladies and gentlemen, to another Be My App webinar. It is awesome having all of you folks here again. My name is Fernando, and for today's webinar, I have the pleasure of introducing you guys to Phil. He is developer evangelist for Twilio, and he's going to be going with us, actually showing us going offline with service workers. As always, if anybody has any questions, please be sure to type them down in the comment section. And without further delay, I'll let the man speak for himself. Phil, you have the mic and screen, sir.
Thanks very much. Thanks, Fernando, and hi to everyone else. Let me just share my screen now so you can see what I'm seeing, and we can get kicked off. Cool. All right. So good afternoon, or it's afternoon for me at least, and wherever you are in the world, good day to you or whatever. My name is Phil Nash, and I'm a developer evangelist at a company called Twilio. Twilio is a communications platform for your applications to communicate with your users via voice, video, or messaging, and using the tools, languages, or frameworks that you already know. If you ever have any questions about that, do find me online at any of these places. I'm at Phil Nash on Twitter and GitHub and all those internet places, or drop me an email at philnash at twilio.com. Cool. So I wanted to talk this afternoon with you about going offline with service workers. It's a really exciting part of the web for me, I think, and I hope to share that with you this afternoon. So firstly, I just want to start with a quick introduction to what the service worker is. And I kind of wrote it down what I thought was a relatively succinct way, and I hope you agree, in that service workers are scripts, JavaScript, that intercept network requests so that web developers like ourselves can treat the network as an enhancement and then provide offline experiences for users of web applications. And that's basically it for me. I think it's an exciting thing that we are able to produce these offline experiences. I'm going to try and show you a few of those today as well. This will be interesting because I can't obviously go offline as this is a webinar, and if I did, you wouldn't hear me. So we'll see how that kind of thing works out as we go through this. But come and join me on that journey. So first of all, for me, this is a great feature of the internet, the XML/HTTP request. It was invented way back in kind of Internet Explorer 5.5 or 5 or something like that, when the Microsoft Outlook Online team said, "Hey, what about we're able to change things on the page without doing a whole page reload or using frame sets." And a horrific API was born, a horrible one, really, when you think about it. I mean, even the API itself doesn't make sense. Like, why isn't T and P capitalized in this? But what it brought about was this ability for us to make these interactive applications online. And that just was really exciting back then. And nowadays, I can imagine, can you even imagine a modern website that doesn't use XML/HttpRequest via AJAX in some way? I don't think so. Only the very simplest kind of maybe content sites that just have documents, just have maybe blog posts even, That kind of thing is fine without Ajax, but most modern applications these days will use that kind of thing. And I believe that in the future, we will wonder how we coped without service workers and without this ability to make sites work offline and make them work better for users in that way. So what does this service worker really do? Well, again, rather than just tell you about it now, I'd kind of like to show you. And so I have an application right here running. It's the simplest possible application that just has an HTML page and some CSS. In fact, this is a template from Bootstrap because I wasn't going to design a page for myself. But I'm going to make it go offline. I prove to you right now that it won't work offline because this is the server that's running that page and it's now offline. And if I refresh this page, it's gone. Now this is faking offline, so we don't get to see the dinosaur of disappointment, the little game that you get when you really are offline with Chrome. But this is the equivalent of this site being offline. Let's start it up again just to prove that. There we go, we're back. So let's go to the code for this application. And that is not the code, this is right here. So as you can see, this is offline apps rock. This is what I'm talking about. And right down here, I've got a script tag so I can put some JavaScript in and install the service worker. So the service worker itself lives on the navigator object, and it's right there. And that's where you can kind of do a test if you want to progressively enhance. Just kind of test, if service worker on there, service worker in navigator. We can do that kind of tech so that we don't break things for people who don't have the service worker. And then we can use it. And what we need to do is register a service worker. So the service worker is a piece of JavaScript that lives outside the context of the actual page, the website that you're looking at. It runs in the background. And so we need to install it. We need to register it with the browser to say, hey, this is our service worker, and we want this to deal with stuff. And all you need to do with that is just point it towards that service worker JavaScript file, and we'll take a look at this file in a minute. You can add some options to this, such as a scope, and you can maybe scope this to part of the website if you like. This would scope it to anything with the path that starts with /admin. But we're not going to do that right now because this website only has one page. So there would be very little point in doing that. In fact, it just wouldn't work. Cool. So when you register it, another thing that service workers use quite heavily is promises. This is not a callback-based system. This is all very modern, new, and promise-based. So when you install or register the service worker, if that registration and installation is successful, then you will receive a callback with a registration object. And right now, we don't need to do anything with that registration, though we'll look at things we can do with it later. But what we will do is just log some kind of excitement because it worked. Similarly, if the service worker actually fails to install, you can catch that error because the promise will reject. And at this point, we'll get an error. And at that point, if everything's gone horribly wrong, we probably want to know about it. So let's log that out as well. And that's all you need to do to get started registering a service worker. Now we should probably go and build that service worker. So service workers, as I said, run in the background, and they're not running all the time. They actually listen out for events, and that triggers code for them to run, very, very much like anything else you do in JavaScript. So what we get is a number of events. And the first one the service worker will receive is the install event. And that it gets when you try and make this registration happen. And this is where we can pass or fail that thing. Now, since the service worker is running in the background, it can actually kind of get killed at any time as well. Like the browser, if it decides it doesn't need it right now, can kill it off. So we can tell the browser, hold on, we're doing some work right now. Can you wait for this to be done? And then we're good. And you do that with this event.waitUntil. And waitUntil takes a promise as an argument. And when that promise resolves, the event is over. Or when the promise rejects, the event is over. So we're just going to pass an event in here. And then we're going to look at one other API for now, because we're going to look at the caches API, which is also fairly new with service workers. And the caches API allows us to open up a cache, put some static files in there, and then retrieve them later. And so I'm actually, rather than using a string there, because we're going to keep using this cache name all over the place, I'm just going to write a cache name up here. This is cache name offline rocks, why not? And we're going to open that cache name, open that cache, the cache called offline rocks, and if it doesn't exist, it will create it. And that, unsurprisingly, returns a promise, as pretty much everything does at this point in the service worker. And that's going to return, when the promise resolves, it's going to resolve with the newly opened cache. And so we need to then add some files into that cache. Now you can add them individually using just add or put, but if you use cache.addAll, this actually takes an array of strings, array of paths, and caches all of them. And if any of them fail, then the promise rejects. And if they all successfully cache, the promise resolves, and the installation finishes successfully. So we're just going to add in index.html and then the rather grandly named app.css. This is hardly an app, I can tell you, but that's what I called it in the first place. And we're just going to do that. So that's our install event. And when we run the service worker on the front end and we install it, this bit will get run in the back end. And I like to call it the back end, and it's definitely not the back end. The service worker to me is almost a middle end. It's very strange, so I end up calling it strange things. And when I say the front end in the course of this talk, what I really do mean is the browser itself in a page that that your normal JavaScript is running in. And so when you register the service worker on the page, this is the install that will run, and this will only succeed if all the caching in this particular case succeeds. But this isn't enough to just go offline. We've cached these files, and that's cool, but we need to be able to return them as well. And like I said, the service worker responds to network requests, and that is where we get the fetch event. And so every time the page makes any request, and that's to your server or to external servers, you're going to receive a fetch event in the service worker. And then we're going to have to deal with it somehow. So in this case, we're actually going to use event.respond with. This also either takes a promise or a request object. And we could actually return a request object here. We can make one up ourselves, in fact. And that would just return hello world for any request, which in this case would only be the first request for index.html, because we'd never request the CSS, because all we'd return is hello world. So that's a bit boring. Instead, we can actually say request. It's a response. Sorry, it's a response object, obviously. Sorry, it's not obvious I'm talking about it, but we return a response object with hello world in it. And so event.respond with can either return that response or a promise that resolves to a response. And we are going to get our response from the cache. And I hope that's unsurprisingly. So in this case, we're going to open up our cache again. And instead of putting things into it, we're going to get things out of it. And actually, all we need to do is return cache.match on the event.request. And that is a request object. So the cache matches incoming requests and then and returns the response. Which is part of a response object. Cool, so that is actually all we need to do in this case. Put some semicolons in, but they don't really matter in this case, as long as I don't break anything. Not putting the semicolon inside respond with is the important thing, because that's a promise and not a function or anything like that. Cool, so what I can do is go back over to the offline page, or the currently online page, and refresh it. And I have DevTools open on the right-hand side of my screen here. And you can see here, and so this is Chrome Canary, so it's the latest kind of version of the DevTools for service workers, and the application tab up in the top right there. And you can then look at the service workers that you have, and we can see that over here we've activated and running this service worker. So what that should mean is that I can kill the server off, and the service worker will take over. And I'm refreshing the page there, and I'll click refresh as well, just to show it on screen. But we are still seeing our page. All of the things are still getting returned to us because they are now cached and offline. And we can actually see that cache. Here is that offline rocks cache that we made, and our app CSS and index.html are living in there. Cool. So let's go back to the slides for a second. Because you might now be kind of asking, why? Why is this important? Why do we want to be able to make things work offline? Or I hope you're asking that as well, because just doing what I say is a terrible idea most of the time. So hopefully you're asking why. And for me, this kind of is a bit of a question of web versus native. This is a question that many people ask and many people argue about quite a lot, but this is my view on it. And I feel like the web and native native applications have very different kind of abilities, and two I think are very important at this point, because the web has always had this thing that is online by default, and this is maybe its problem, right? Because every time you need to use the internet, even if you have cached files in, say, the HTTP cache in the browser, it's unlikely that the website is going to work if you go offline, if you lose your Wi-Fi connection, if you are on a mobile device and you go into a tunnel or underground or whatever like that, you are unlikely to get hold of that internet that website. Whereas native applications are absolutely offline by default. Once you do that that initial install from the App Store, your application, a native application, should have all the files and all the assets it requires in order to run and give the user some sort of experience. By default. Now, it is possible that a native application developer may have programmed their application such that it requires a request to the network straight away, but that's their fault. That was their problem. They have spoiled their advantage in this case, and that's not so great. But all native application developers have this ability to be offline by default and give an experience to their users. On the other hand, the web has discoverability. We have search engines that point people to our sites, and we have links that you can share. And the link truly is the best part of the internet, as it is it is that thing that networks and joins all different parts of the web up. And you don't have to go through any kind of app store or any kind of gateway at all in order to use a website. On the other hand, native applications have the worst kind of first-time user experience you can expect from any kind of application. And that's because you have to go through the App Store installation. Now, perhaps you are on the internet and you're trying to get something done, and the website you're on says, hey, how about you install our app? And you go, okay, that sounds like a great idea. First, you have to, knock out into the App Store itself or the Play Store or whatever store that your device is on. You have to, you probably link through to the actual application at that point, but then you have to click the install button and agree to a bunch of stuff and sign into your account and all sorts of things like that. And then you go through a download, and typically I've found that applications, particularly important and decent ones, are much larger in size to download than a web app. I mean, even if we take the average size of a website in the top 1,000 these days as 2 megabytes or 2.2 megabytes, which I think it is, apps are typically larger than that. At around 6, I think, was the last 6 megabytes per application on average was a stat I saw. But I think that came from 2012, so it's probably larger by now. And you install this application, takes a while to download, and finally you load it up, and the app has no idea what you actually came to do there in the first place. Meanwhile, the website you were on still knows what you were supposed to be doing, but now you have this application installed, and it's like a new person. You're like a new person to it. So that's App Store installation. It's a horrible thing if you ask me. It's particularly horrible when you're trying to do something on the web and somebody pops up that little thing saying, "Hey, download our app," because that just ruins the experience for me. And so I think that we're looking at service workers and this ability to take the internet offline, take websites offline, and that is where we get to change the game in this comparison, because we can now make our websites work offline first and produce an experience for our users that will work as if it was a native application, but without kicking them out, without making them go through an installation, and maintaining the discoverability that we have from the web and from links and from all the sharing you can do like that. So that's why I'm excited about it. But maybe you don't care about offline. Maybe you don't want to take your entire application offline. There are still things I think that the service worker can do for us, and that's what I think is exciting. Because think about performance, for example. If you've just taken your static assets and cached them into the service worker cache, which is something that you have control of and something that you can pretty much guarantee they're going to be there, unlike in the HTTP cache, then you are able to serve those assets ridiculously fast from that cache, and just have to load the rest of your data, or maybe just the HTML page that's sat on. You could also pre-cache some things. So if you if you land on your home page and that doesn't contain all the CSS for your application, or all the JavaScript for your application, then you can start loading that in the background in that install event, and then the rest of the site is going to work so much quicker. Similarly, fallbacks are pretty good as well. So I'm talking about experience a lot for users, and being able to use an application whilst it's offline is a great experience. And the worst experience is either where you go to refresh a page or go to the next page, and the browser hangs with a white screen saying, I'm trying to get this, but I can't get hold of this page right now. And or the browser believes it's completely offline, and if you're in Chrome, you get to play that great dinosaur game, but you're not seeing the application, you're not seeing the website that you visited in the first place. And we can do better than that. We can keep people, we can still give people an experience, even if it's not the intended experience for the site, by giving them some sort of fallback. And one of the best examples of this I've seen was an experiment done by the Guardian developers on their blog. And if you are on, I believe it's still an experiment, so you have to go to the actual developer blog in order to enable this. But if you go to the developer blog and you have a browser that that supports service workers, and then you disconnect from the internet somehow, you don't get the dinosaur of disappointment. You don't get any offline pages. You do get this nice page here which says, you're unable to connect to the internet. But in the meantime, how about a quick crossword? And what's great about this is, if you're offline on this page, you're offline on everything else you might be, on any other tab you have open in your browser. And so there's no point going somewhere else. So this crossword kind of keeps you there with the Guardian. And, perhaps this is something that works particularly well for commuters. If you go through a tunnel and, they're reading the news and now they can't read the next page, but don't worry. There's a crossword to enjoy in the meantime. I just think this is a really great fallback experience. I mean, there could be a simpler fallback experience, which is something like just saying unable to connect to the internet, but don't worry, I'm sure you'll be online again soon. But this is a particularly nice one, I thought. And there's more. There are more features to the service worker than this offline capability, and I will touch on a few of them later, and we'll see them in action, hopefully. So I guess at this point, it's important to ask, how are we going to do this? Because clearly the code I just wrote for that simple offline website is just a little bit too simple. And you'd be right, because if I were to go and say change something on this page, let's go and change the title. Say hi, be my app. And then I go and reload this page, it doesn't change. And that's because my service worker has cached all my files offline, and it never reaches the actual server again. So we got to do something about that. And I actually want to just introduce you to another example application that I've been working with recently in order to discover various bits about service workers and going offline. So this is an app I'm writing. It's a website. It is using Google's Material Design, and Material Design Lite framework. So it looks like it might be a real application, but it's not. It's definitely a web app. And what it does is it uses the Twilio API to send and receive text messages. A very simple idea, but and everybody has an SMS application, but this one is one that would work for a Twilio number, which doesn't really exist in the world, or not without paying for them anyway. And so my idea here is that this application should be able to work. You should be able to read messages that you've got that you've received. If you're offline, you should be able to send messages when you're online and receive other messages when you're online. And that's what I've been working on right now. And so this has kind of led to a bunch of the things that I've discovered about service workers and about making offline applications. And I say progressive enhancement right now because I built this application without any JavaScript to start with, or it has the JavaScript from Material Design Lite, so the menu does a nice pop in from the side and things like that. But that's the only JavaScript it started with. And I was really pleased to be able to do this because it truly proved to me that service workers work very well with progressive enhancement. The idea that you can take an existing application, something that's been built to a decent standard already, and add in offline support without having to rewrite the whole thing from scratch is just really exciting. And it means that all the applications out there, all the web applications out there can benefit from this without too much work. Obviously, the size of the application will determine the work, but it is not a ground-up rewrite that everybody needs. And that's cool. I've always been a great proponent of progressive enhancement on the web, and this is not time to stop with that. In fact, progressive enhancement using the service worker is an absolutely brilliant feature. So what do we need? In order to create ourselves, create an offline experience for our users, what do we actually need? I think there's 5 things I'm kind of talking about today. There's a base experience, like I said, the existing application. We need to do something with our static assets. We need some way to make the rest of the pages work offline. Background sync is a fantastic feature that is very useful in situations where you want your user to perform an action, but they shouldn't need to care whether it completes or not at the time if they're online or offline, something that will eventually happen. And then finally, push notifications, which I think are one of the most powerful things that the service worker also brings to us, and is really another thing that's had me very excited for quite a while since seeing that this was going to come out. So let's talk about that base experience. Good news. Like I said, we just need to work from our existing websites. You have a base experience. If you have built a web app, a website, you have this base experience already. And hopefully you've built it in a good way, in a progressively enhanced way. But basically, it doesn't matter. We can start building on top of our base experiences, enhancing our sites with a service worker progressively, whenever we want, as soon as we want to. And secondly, I mean, this second exciting thing is, that if we don't pass this service worker check in our JavaScript, then we can actually we can just forget about things, and the site will continue to work as you expected it to in the first place. It will continue to work as it did as a website that doesn't work offline, which is fine. That is great for any browser that doesn't support service workers, because that's all the users are expecting. And we just have this ability to surprise users by making it work when we are online. So cool. Let's talk about static assets then. So we saw that I've already broken this site because I stored all the static assets offline, and now I can't change anything. But let's make a change. Let's make that happen. So if I just change the cache name to offline rocks1, this makes a change to the service worker itself, and that means that the browser is going to the browser continues to ask for the latest service worker, even if it's ignoring the index.html and the app CSS. And so if we do that and I refresh the page, what we can see, that's interesting, it's disappeared. We got an error. Yeah, that doesn't seem right. Oh, because I've turned this thing offline. That's why. We actually have to have the site online in order to make that work. Let's try again. What we see is we've got a new service worker and we're waiting to activate it. And this ties in to the service worker's lifecycle. So I'm just going to show you the service worker lifecycle because it goes through a number of events. We've seen some of these already. So when you register a service worker in the first place, we go to the installing event. And this is where the install event is fired and the state of the service worker is installing. Then once we complete that install event, the service worker is installed. However, it's not yet running. It's not yet activated. And that's the position of this number 994 that you can see in the dev tools. It's currently in that position where it is installed, but it has not yet activated. It's not running yet. And we can actually see, if I refresh the caches, we've got this new cache offline rocks 1 because we've gone through the install of this service worker, this new service worker, and we've cached all the things offline. And this is going to be index.html that has the text in it that says, where's it gone? That says, "Hi, be my app," but it's not yet active. And so then the service worker will go through an activating event. And this happens for a number of reasons. Firstly, you can see there's a link next to the waiting to activate service worker, which says skip waiting. And that is a method you can call on the service worker. And I'll show you where that will come into play later. Or if you were to have this button at the top of the DevTools here checked, which says update on reload, if you have that checked, then this is a great thing to check when you're in development and writing your service worker, because it will instantly replace service workers. It doesn't go through this life cycle anymore. But the natural way for it to actually happen is if you were to close all the tabs that have this service worker, have a page which is controlled by this service worker in running. So I'm just going to close that page and then open it back up again. That's my simple offline page. And now you see it says, "Hi, be my app." And our service worker number 994 is activated and running. And so that's what happened there. We replaced our service worker because all the pages it was controlling were dead. And so it had nothing left to do. And the new service worker took over when a new page was requested. And we got the latest cache. So that's pretty cool. One problem is that we actually still have the old offline rocks cache here as well. And so we should do something about that. Let me just finish. So we have activating, and activated is that point where the service worker then takes over. Either when you click skip waiting, you call skip waiting on the service worker object, or all the pages are closed and a new one is opened. And finally, there is a state of redundant, and that is in the case of a service worker that never actually gets to activate it because it's taken over by a different service worker that's changed in the meantime. Cool. So as I said, we still have our caches that we had already, and so we need to look at some cache invalidation as well. And if we go back to the code here, I'm just going to write some more stuff in our service worker file because we don't want those caches hanging around forever. That's just going to clog up a user's device. So we can listen out for the activate event and do stuff with it. And in this case, what we're going to do is just clear out the old caches that we don't want anymore, so we don't take up too much space. This is a great part of the life cycle of the service worker. In order to invalidate those old caches, clear stuff out that you no longer need because the old service workers have gone away now, and that's what we're going to do. So first of all, we're going to tell the event to wait. Otherwise, we might get things killed. And into that, we need to pass a promise. So I'm going to actually use the caches API and get the caches.keys method, which returns all the names of the caches we have. As you see, I actually have 3 in here as I was going through this demo before, and this is an old one. So we've got LWS2, we've got offline rocks and offline rocks 1. Now, offline rocks 1 is the one we want to keep, and that's the one we have in cache name here. So we want to filter through those keys. Hold on, sorry. So keys returns a promise, which resolves with an array of names of caches. So we get the names here. And in there, I'm actually going to wrap this in promise.all. I don't need an array for that. I'm going to wrap this in promise.all because eventually we're going to return promises from this array of names. So first of all, we're going to filter the array because we don't want to include the cache name that we want to keep, which is stored in our cache name variable. So basically, we want to return any, we want to filter out anything that's not our current cache, which is basically that if the name is not equal to cache name. And then we're going to map over the names and return promises because we're going to try and delete the name. So that will return promises to promise.all, and when all the caches are successfully deleted, then promise.all will resolve. This outer promise will resolve an event.wait until we'll get a resolve promise and complete. So we need to go through our update cycle again, and in this case, I'm actually just going to check that update on reload button. So this means the second service worker is going to take over and activate straight away. Should we see that happening, or did I get an error? Nope. Have I taken this offline again? It's always a good question, no? Check that and see what's going on. What's going on, service worker? So inside this DevTools here, you can actually inspect service workers at the time, and that's pretty cool. And I don't know what's going on with that. This is great fun. It doesn't seem to believe that there's anything different, which is interesting. So I can look at the source, and it still has the old one, which is very fascinating. I'm just going to close that page and try and open it up again. Maybe that will work. Look at application. We still have 994 running. I'm going to stop 994 because, and then unregister it because I'm unpleased with it. And it's going to, so we do have an error somewhere, an unknown error, which is totally unuseful. So let's work out what's going on. I need to return that promise.all, presumably. Okay, that, have I thrown the, I don't put anything in that wouldn't be normal. All right, I'm going to have to move on from that. What would have happened is we'd see our cache cleared out when that application, when that activate thing runs, and I will discover what happened to that later, and I will publish the code so we can all see about that, because that has worked for me several times before. In fact, I do have a backup here, which has the same thing. So is that what I've done wrong? I'm just going to copy this one into place. Don't see anything different there. It's still not happy with me. So don't know what's going on there. That was an existing thing that worked. We'll move on from that and get back to the slides. You can just trust me that that should work. Because we have more to think about when it comes to that cache invalidation and taking over service workers. Because we don't just have to we don't have to wait for all those tabs to be killed, and obviously we can't expect users to click skip waiting inside the DevTools. So what you can actually do is when you register the service worker as part of that install script, and when that resolves successfully, we'll get that registration. And you can listen to the registration for an update found event. And if there is an update found event, it means we got a new worker that's installing. And so we can go get that worker and then listen to it. So listen to events on that, including the state change. And once we get to the installed state, we have that worker ready. It's ready to go. And this is a point where you can decide what to do with it. And one option you can make at this point is to use the post message API, which just it lets you send a message from the page down to that service worker. And if you send something like action update, you can send other actions at other times if you wanted to. But right now, if you send that, you can get it to skip waiting, and this is the same as that link in the DevTools. This is basically all it's calling, and so you can listen for those messages in the worker And if you get that update action, then you can call self.skip waiting, and the service worker will take over everywhere. And you can then notify the front page, the page again. In fact, you listen to the existing service worker, and if you listen for the controller change event, you can know when the service worker has been changed underneath the page. At that point, you can decide what to do. If it's a very small change, you might not need to reload the page. You could just perhaps update some things in your JavaScript. Or the simplest and kind of most comprehensive way is just to reload the whole page, which will load all the new assets, the new service worker, and everything else. So this allows you to take back control over your site, over your caches, and over your service worker. I think it's pretty useful to know that kind of stuff. Cool. So let's talk about offline pages then, because we've seen caching static assets. And in fact, you've seen me cache the index page, which is maybe not the most sensible thing, because on a website, we tend to have data and static files, static bits. In the case of my SMS application, you can definitely see that the data is the messages sent to and from various numbers. However, we also have obviously CSS and JavaScript on that site. So those are files, static files. We also have, there is also a new message form in which you can send a message to any number, and that doesn't actually have any extra data with it. It's just a simple form with a couple of fields in. And so that could be static as well. But when we're doing this with our service worker, we need to think of ways that we can get that data stored as well. And this is where I've ended up reaching out to IndexedDB. Now, I don't know if you've tried to use IndexedDB before, but most people's response to it tends to be a bit of shock, a bit of horror and revulsion, as the API for IndexedDB is not the most pleasant. It has all sorts of weird callbacks based on how it works. And it's because it was designed before the Promise API was properly designed and implemented in browsers. So we end up with a lot of weird callbacks that you don't tend to want to have to deal with. However, the world is a lovely place, and people have produced libraries with which to use IndexedDB, and this is makes things much nicer for us. So first up, I just want to mention a few of them because I'm going to be taking a look at one of them quickly. But first up is the simplest, which is called IDB Promises, written by Jake Archibald, who also wrote or helped to write the spec for the service worker. And IDB Promises is just is basically the same API as IndexedDB, except all the callbacks are replaced with promises, so it can be used in a more sane and promise-like manner. It still follows the rest of the API, and it's quite good if you want to learn how IndexedDB works properly, but not have the horror of crazy callbacks. Local forage is a library written by Mozilla, and this replicates the local storage API over IndexedDB. That might sound redundant, as we have the local storage API, but in places like service workers, or in service workers particularly, they've been tasked to only use asynchronous APIs. And local storage is a synchronous API. So local forage allows you to use a key value store in IndexedDB with the simple API of local storage, and it will work offline. And it will work in a service worker asynchronously. Dexy is a slightly higher level than IDB Promises, but still has a feeling of the IndexedDB API, but it is much nicer. It's a lot more syntactic sugar that makes it a pleasure to work with. And finally, PouchDB, I think, is an incredible piece of work, as it effectively replicates the entire of CouchDB, the REST-based database in JavaScript over IndexedDB, but it also actually does it over Web SQL and local storage as well, depending on the capability of the browser. In this case, we want it for IndexedDB, but it's built to work in as many places as possible. And what's brilliant about it is not only is it a nice way to store things in IndexedDB, it also comes with the CouchDB sync protocol, which allows it to sync to external databases as if they were just another installation of CouchDB. And so this is great for syncing data back to the server from your users, or back to the database, really. And very useful, but a little bit too much work in terms of the applications I'm thinking about at the moment. So I've been looking at DXE mostly, which has been it's been fun to work with. And so this is how you'd work with that. I don't have time to write this right now, but you just get yourself a new database. You call it something message store in this case, and I use the auto open true option there so that the database just opens straight away. At that point, you can start kind of migrating the database up. And so with IndexedDB, you do have to keep all the history of the migration of your database from version 0 to version whatever you got to, so that any browser at any time coming to that page and using that JavaScript will be able to replicate the whole database, or at least its structure. And in this case, we just need version 1. And we define the stores that are in this version. And so I only have one store, one kind of table of messages, and that has 2 named indexes. These aren't the fields that are in the store, they are just indexes. The ++ in this case is a hidden auto-incrementing key, because I didn't really need a key for this particular application. And then the created at field means that I'll be able to sort and search on the kind of created at date of any message. And then this is how you'd add a message into that database. IndexedDB works with transactions all the time, so you have to open up a transaction, and the W at the top means it's a write transaction in this case, and you have to name which tables you'll be using during this transaction. We only have the one, but we still have to name it at this point. When that transaction, within that transaction, we just use the db.messages and put an object into that message, into the database. And that's all you need to do, really. It returns a promise, which resolves when that's successful. And there we go. We just put in the data we need, and you can use arbitrary kind of objects in this particular case. And then when you want to read them out, you just do a read transaction on the database, and you can just call each over all the messages in this case, and you'll get each item, and you can render it out somehow. I don't care how you render them things. You might be using the fanciest of new frameworks, or you might just be writing HTML with jQuery. But this is the kind of place where you would render an item like that. So I'm talking about rendering in the front end at this point, but I want to make it key that when we're dealing with stuff like this, it is best pretty much at all times in terms of both performance as well as accessibility and even SEO to render things on the server. Render your HTML on the server first, because that is going to get that HTML to users before the quickest, and get them using your application as fast as possible. And so this is what I'm doing in this application right now. The API is called in the back end, and we render HTML. But then you might be wondering, how do we then deal with this this database that we're using in our client side? And this is where we come to the app shell architecture, which is being pushed by people using service workers quite well. The idea of the app shell is simply to produce a different bit of HTML. So don't store your just index HTML, because that has all the data in it. Produce a different thing that has the outside bits of your application, such as the header, the navigation, the footer if you have one, and then fill that in afterwards. When so you return this app shell for any request for HTML from your service worker, and then based on the path, based on the URL, fill in the application with the bits that you then expect. And so your application will have to be built so it can bootstrap that data from either the page, extracting it out of either the HTML or by including a JSON object on the page as well, or from the database in the case of when you start from the app shell. And at that point, once you've bootstrapped, the app should be able to work as normal. It just needs to bootstrap either from the HTML or from the database. And this is kind of an idea of universal JavaScript, I guess, like the ability to render the same thing both on the server and then on the front end. And there's some great frameworks that are doing great work with that right now. I want to go quickly into background sync because I think it's a very cool feature. And I have a demo straight up for you. In fact, I'm running quite over in time right now. So I was going to show you a demo using this application, which I've killed.
You're actually pretty good on time.
Pretty good on time. Okay, cool. Thank you, Fernando. I appear to have killed an application. Oh, that's dead. It's definitely alive there. That's okay because it wasn't working earlier anyway because it's not quite offlineable. So I want to show you what I was going to do is show you the messages and the ability to send a message whether the application was online or otherwise, which I think is quite useful. But instead, what I have here is an example from Jake Archibald. This is an offline Wikipedia demo. And he's just built this kind of shell of an app. As you can see, there's the kind of app shell architecture here with the header and search is all you really need in order to start this up. And then we have this index page, which has anything that's cached offline, which is kind of cool. So I can just go straight to that. And I have this offline page about Twilio. But if I then make the site go offline, and I'm doing this using the service worker, the dev tools again, which don't exactly work as you'd expect, but let's see. I'm going to click just onto WebRTC here, which is a great feature in the browser for real-time streaming of data to your peers. And because it's offline, it's been caught. The site's caught it and said, hey, I can't do that. But we can say, all right, let's load that in the background then. And what that's done is register an event to say to the service worker, when you're back online, go do some work. And so if we can click around to our existing offline things, but we don't have that yet. If we uncheck the offline box, we go back online. But what I've found so far is that this doesn't trigger that sync event like really going back online would do. But we do have this ability, this little thing over on the right that's going to trigger a sync for us. So if I hit that, what I will actually get is WebRTC ready, and so a push notification here to view the article. And now I have the article on WebRTC in this offline thing. And that is how background sync works. So let me just show you the API for that because it's very straightforward. If you have a registration, this is what you get when the promise resolves when you register the service worker. And if you have the sync object on that registration, then you can just call register. And as I said, I was using the message, or trying to use the message example from my SMS app, which for some reason has died. But you register for a particular tag, in this case, sent message. And that just says, all right, I would like to know when we're back online. And then in the service worker, all you have to do is listen for the sync event, which will be triggered when you're back online, and then do the things you wanted to do. And so that's where, in this case, in both the case of Jake's demo and my own, we both put things into IndexedDB. In fact, this key value store. And so I'm just going to do the same thing again, just to show you that works. So we're offline. We'll go to Twilio, and then we'll try and see web service. Right, we're offline. Load in background. I'm just going to look inside this key value store here. I think because this is a key value store, I believe that Jake is probably using local forage for this one. And as you can see, there's just an array of web service, because this is the path of the URL that we'd want to get from Wikipedia. And so when you register the sync, you should also put something into IndexedDB that you can collect later when you get the event and know what to do. And so this is the point where you'd go and download the thing from Wikipedia, and then when that's done with, send the push notification back to say that was successful. Yes. And then finally, as you saw in that example, in fact, we have push notifications working as well. And so I won't show you that demo because you just saw the push notification work. But the idea there is very much the same almost. What you do is we have notifications, and I'm just going to change the permissions for those notifications for the site right now. which is offline. And we can put it back online. And then I'm just going to go do the same thing again. I'm going to go get a page that doesn't exist, load in background. And at this point, you can ask for permission to use those notifications. Very much like if you wanted to use the web notification API in the first place, you need to ask permission. So if I can allow that, and then so this means that I get given an endpoint to send notifications to as a developer for that user, and it uniquely identifies the user and the browser they're using. And then when you can then use your server to send a push notification by making a post request to that URL, to that endpoint, and the web and the service worker at that point will receive a push event, much the same as any of our others will actually receive a push event. And I just, if we just have a quick look at what that might look like, I'm not actually going to run this particular code, but you get the push event. And at that point, I'm going to ask it to wait, but we can actually just use the registration of our service worker, which will have a, we'll be able to call the show notification method, which takes both a title and then an option of, a object of options, which can include the body and some other bits, including an icon and an image to show in that notification. So that's how that would work. And then, so if we update the sync, we're not offline yet, are we? If we sync, you get the push notification. And it is important to note at this point, there's a little settings box there, which means you can go and turn off push notifications for anything right here. How would you do that? So you should be able to block it. There we go. So you can go and block push notifications right here. So if you do decide to use push notifications at all, be wary that they're very easy to turn off. And finally, you can program it such that when you click on the notification, we then open up a new tab or open up an existing tab, make that live. And that's how you'd use push notifications. Cool. So that's kind of what I've been thinking about when we're going offline with service workers like this. And I think it's an exciting place to be. You know, the things we need in this case are that base experience that we should already have as a site. Some way to cache those static assets so they can just work offline. Some way to keep our pages working offline, either by storing our data in a database or caching other fragments and using that application shell architecture. Background sync so that you can let users perform actions and it doesn't matter to them whether they're online or offline. It will get done in the end. And then push notifications, which are very useful for notifying things like when the person is offline. When the person has come back online, like in the Wikipedia example, or the example I've been working with my SMS application is when an incoming SMS comes to my Twilio number, I will send a push notification to alert the user. And as I said at the start, I do believe that in the future, we will wonder how we coped without service workers. And I hope you do too, because they are magical, wonderful things that deserve an explosion to finish this kind of thing off with. And this is actually, this is just a clip, a GIF caught from the end of a video which advertises a course on Udacity that teaches you everything you might want to know about offline applications. And I highly recommend checking that course out on Udacity. So that's all I've got time for, I think, this afternoon. I have one tiny plug before I finish, because as I said, I work for Twilio, and we're running, if you're in London or Europe, or even if you fancy coming all the way over here from anywhere else, we're running a conference ourselves in September, on September the 20th, called Signal London, in which we're talking about communications. And it's everything from this, very basic stuff we can do with SMS these days, all the way up to WebRTC video chats and chatbots and other things like that. So we'd love to have you there. And so if you are interested in that, please do use the code PNASH20 and you can get 20% off of the price of a ticket, and you'll make me very happy. But otherwise, that is all I had time for and all I have for you today. And I'm very happy to take any questions right now. So thank you very much.
Perfect. Phil, thank you very much for that. Very awesome.
No worries.
You see, I think everyone pretty much understood it. I think nobody got lost. I think everybody was well on track. Folks, as always, to the people that are coming late, I usually mention to everybody else that if you have any other questions when you're coming in late, feel free just to type in the comment section because we're always checking them. And I will always be happy to email them to Phil. If he ever has some spare time, he can always.
Oh, absolutely. And as you can see, I've popped my details back up on the screen as well. So do hit me up on Twitter or email if you have any questions.
As always, yeah, folks. And to the people that are watching it, if you guys want to watch it again, just feel free to refresh the link. And to everyone else, I see a thank you, a big shout out again to Twilio and to Phil. Man, I really appreciate you coming down and showing us the works again, folks. And don't forget about his promo code, which I think was PNash.
PNash20.
PNash20. There you go. Ladies and gentlemen, thank you very much for coming and have an awesome day. Cheers, folks.
Cheers. Thanks very much.